In our last lecture, we will take a look at a few applications where you wouldn't expect to see recursion, but it's there. We'll also settle the debate between which is better, recursion or iteration. What we're going to do now is take a look at some situations where recursion is actually quite useful. We've seen some different types of problems and applications before, but what we're going to see here is that recursion can appear in some very interesting and some quite odd places. So here we're going to take a look at two particular problems. One problem is going to involve trying to fit items into a knapsack. And then another one is going to involve choosing members to form a mountain climbing team. Now, I do want to mention for both of these problems, we're not going to give actual Java code. We're just going to give the high-level description of the problems and how we would use recursion to solve them. But we're not going to give any actual code to solve the problems. The first problem we'll discuss is what's called the knapsack problem. The knapsack problem is actually a classic problem in computer science, and there are several variations of it. So the idea with the knapsack problem is that we're trying to fit items of different weights into a particular knapsack. And we want to make sure we fit enough items of these weights so that the knapsack ends up with a specified total weight. So that doesn't mean that we need to fit all the items. In fact, for a knapsack, there might be some capacity where we can't put more than this amount of weight into the knapsack. So we're just trying to figure out if we need to achieve some type of weight and we try to put items in there, what items do we need to pick in order to get that specified weight? So for example, let's say we want our knapsack to weigh exactly 20 pounds. And we have 5 items. One weighs 11 pounds, one weighs 8 pounds, one weighs 7 pounds, one weighs 6 pounds, and one weighs 5 pounds. So we need to pick so many of these items such that we would get exactly 20 pounds. Well, what we would find is the answer to this is we would put in 3 items, one with weight 8, one with the weight 7, and the other one with the weight 5, and that would give us exactly 20 pounds. Here's an algorithm that we can use on a computer. So the first step is at any point in the process, if we find that the sum of the items that we pick adds up to our target, then we're done. We got our target weight. We don't need to do anything else. There could be more than one combination of items that gives us the target weight. We just need to find the first one. So as soon as we get our target weight, we can stop. Now, let's say we haven't found it yet. We'll start by picking the first item of our set of items. That means that the remaining items must need to add up to the knapsack's target weight minus the weight of the first item. So that would become our new target weight. So we're assuming, let's assume the first item is part of this set that we put in the knapsack. So let's see if we can get this new target weight. So in that case, we would try all the possible combinations of the remaining items. So we would just try one combination at a time, whether it's just pick one item or 2 items, but we would try all the different combinations. Now, if none of those combinations work, then we know that the first item cannot be part of the knapsack. So we just take out the first item, and then we repeat this whole thing again with the second item. So we would pick the second item, and then the target weight would need to be the weight of the knapsack minus the weight of the second item, or I should say the weight of the knapsack's target weight, I should say. But we have our new target. We try all the combinations with the other items, not including the first item, because we know that can't be part of it. And then we just keep repeating this. So we would continue this on with the third item and the fourth item and so on until we tried all possible combinations. If we have exhausted every single combination, then we can conclude that there is no solution to that particular problem. So if we used our earlier example, then here's how we would run that algorithm. So our initial target is 20, and we would pick the first item. So we would pick 11. The initial target was 20, so we'll adjust in a second. So what we want to do is try all possible combinations of the remaining items to see if we get our total target weight. So our target now would be 9. We add 8 to it, so we're still a little short. So we'll put 8 in there and assume that it's part of the knapsack. So now our target is 1, so we need to try the others. So we would try 7, and we see that's too much, so 7 doesn't work, so let's take that out. Then we can try it with the next item, which is 6. That's still too much, so 6 can't be part of it. And then we'll try 5. The target's still 1. That's still too much, so that doesn't work. So we can tell from this, after trying all these combinations, that 8 should not be part of, well, at least at this point, 11 and 8, I should say, is not part of the knapsack. So then we can try 11 and 7, and we go back to our original target where we're trying to fit 9. So this means that we would have 2 left over. So we still need to fit 2, but we need to try all the combinations. So we would try 11, 7, and 6. Well, that's too much, so that doesn't work. So we take the 6 out. So we'll try the 5. That's still too much, so that doesn't work. So we know that 11 and 7 together does not work. It will not be part of the knapsack. So we can try 11 and 6 and see what that does for us. So that means our target at this point is going to be 3. So now we can try 11, 6, and 5. And that's too much. That doesn't work. Okay, so we know at this point that 11 and 6 together will not be part of the knapsack. So we can try 11 and 5. And so our target from this point would be, let's see, we need 9 minus 5, so that's 4. Yeah, so our target would be 4, but we've seen that we've already tried all the combinations with 11, 5, and all the others. So we know that at this point, 11 cannot be part of the knapsack. So we take 11 out. So now we'll start with the second item, which is 8. So we're going to put 8 in here. We're back to our original target. So we'll see here that our target weight is now 12. So with the remaining items left over, the 7, 6, and 5, let's see if we can get 12 in here. So we'll do 8 and 7. So 7 is a little less than 12, so we can still fit another item here to see if that works. So we can add 6 to it with our target being 5, and we see that 6 is too much. So we take out the 6. So now we try the 5, which was the new target. So we see that this combination actually works. We have our target weight, so we can immediately stop and say that we would have the items of weight 8, 7, and 5 be part of the knapsack. We can actually use recursion to help us with this problem. So the recursive routine can pick the first item, and then we would check to see if that item is smaller than our target. If so, then we can have the recursive routine call itself and pass the new target in order to take a look at the sums of all the remaining items. So that's all we're doing here. We would just call the original method with our target. We would pick an item, and if that item is equal to the target, we're good. If it's less than the target, then we would call the method again, passing the value of the new target and see if we can add some more items to our knapsack.